All right, I am back for more of this PE COFF generator project. And as always, I've got my screen here to remind you that you can help to fund this project by becoming a supporter or a member and unlock a bunch of cool perks that come with that. So it's up to you, but I do count on people like you who are watching to make that decision to keep this thing going. So where the project is at as of right now is I'm working on trying to generate a DLL that can actually be loaded. And I'm getting there, but one of the things I have to do is I actually have to generate an export table. And in order to do that, let me show you some of the things I've done. So I did some stuff off stream. So we're trying to put the export table into the section called rdata. And for the first time, this is a section that is not going to be just hard coded like the text section has been and the data section was. The R data section is actually going to contain data that is generated from an export list, and we want to be able to make that export list conveniently. We want to sort of structure that automatically. So I have this export table that I can create. It creates a list of exports, and it keeps a count of each export plus a count of each name. Each export then can contain a symbol label, a symbol forward name, and a list of names. And so this name count here is counting all of the names across all of the exports. Usually we could think of it as each export is going to have one name in this list, but it's allowed to have 0 or more than one as well. So the number of names is separately counted down here for the whole export table. Then what happens is we build an export table like this. We create an empty one, and then we stick the square procedure into the export table, and finally we bake the exports. And the way that works is we take the section that we've already set up. We set up an empty section here and we pass it in. And then the bake exports function is going to add in data. It's going to push data onto the section in chunks and fill it in. Now the reason that I have to do it this way, the reason I can't just build up the data block, right? You could imagine I would just use like a string list or something. I would just build up some raw data and then flatten that and attach it all to the section at once. But the reason I can't do that is because I also need to be able to use generator pointers, right? So as a reminder, the idea of a generator pointer is that we have this block of data that we're trying to output, right? The final data we're trying to output. And sometimes that data contains pointers. So a pointer in that data is relative to the beginning of the file. So at the very beginning of the file, right over here, let's say this is 0 and it's going to grow. Actually, I don't know which way my camera, is it like stage rules, right to left? Yeah, it is. Okay. So if this is 0 and we're going to grow from right to left, you know, the addresses in the file, then somewhere in here there's a pointer and it wants to point somewhere else. So let's say here's my pointer and it wants to point over here to this address. So whatever number I put here is based on how big that jump is there. And I don't necessarily know how big jumps are, right? I might have multiple data sections that are going to get rearranged, and those data sections might not have known sizes, right? This data section here is getting built, and this isn't necessarily the only thing that would go in our data, right? If I have exports, that goes in our data, but so would imports. Imports would also go in our data. Other stuff would go into our data. So we don't know how big each section is going to be, which means we don't know necessarily where the file offsets are going to be to those things. And furthermore, in the case of binary files, we actually have two different layouts. There's the file arrangement, and file offsets, but there's also the virtual arrangement and the virtual offsets. And a lot of times what I want to do is when I'm storing a pointer, I'm storing that pointer according to the final virtual layout. So for instance here, I have this array of exports. Each export, you can think of it as a pointer to the beginning of some function, right? There's a block of executable code somewhere in the file, and there's a main and there's a square function. And so there are two different pointers, right? The text section plus 0, the text section plus 6 gives me two different function labels I might care about. And so I don't know where that text section is going to end up in the virtual layout necessarily when I'm generating this part. I know that I want something relative to the text section plus a certain amount. That's why I'm using these symbol labels. The symbol label is basically the information about where it's a point. The symbol label is like a pointer to a thing that doesn't have a final location yet. It is unresolved in the final layout of the file, but we know how to track it because it's some section plus some offset. So I can make a pointer to main, I can make a pointer to square as labels and save them for later. Then once layout has occurred, all the generator pointers get applied and fill in the right values. So this is saying there's 32 bits at the location that starts with the exports plus 4 times the number of exports like the index of the export we're trying to actually write. And the pointer we're trying to point, this is trying to point to this label. So we save all of that for later, and later the generator pointer actually gets resolved to fill in that export slot. Okay? So because I'm doing it that way, because that's how it has to work, I have to use a data section. So a data section is actually more interesting than just an array of bytes that is growing. A data section is also these fix-up pointers that get applied after layout. And that's why I need a section, because I'm going to be growing, because I'm going to be attaching these pointer fix-ups as well as everything else. Now, what I could do, right now this isn't done, right? So if I run the build, and then I generate my file, and then I try to load it, we'll see I still get procedure load fail. And that's because I haven't actually finished making this work. So there are two different paths I could take today. I could continue to hack at it until I get it working, and that might be worthwhile. Or I could start to clean up this API. There's a lot of stuff here that is like half thought through, and it is clearly feeling sloppy to me. And I think there's an advantage to getting that cleaned up. I think right now I'm curious to see how much more push I have to do to actually make it work. So let's start here. Yes, reload the changed file, redo the diff, and let's start from the beginning and figure out what's going on. So C0, timestamp. Okay, so the timestamps are different. That's fine. The version of the linker number is different. What is this one? 140 RVA 8220. Right, so I still don't have after I bake the exports, what I should probably do is I should get I get the size before and after to give myself the range. And then when I go to bake the file, this is a V off and a size. Okay. Okay. Man, it just keeps coming up with fancy stuff to throw at me. So the data directories are V-offs, huh? So I guess we want the label that you get right there. And the reason a label is nice is because then we can do something like we do something like this. We want the we want to set our directory. Like that. Right, and then we need to go implement the data directory helper thing. Should look like this. Okay. Now, here's a question. Has section layout already happened? Looks like it has. Good. Okay. We need to get the layout needs its own copy of this same thing. Data directories. Context. Zo Lorenzo, hello. Welcome. This editor is called Forcoder. This is an old website for it. If you go to the very bottom, there's a link here to the Discord. And there are people there who maintain a open source fork of it now. But the version I'm running is the last official version that was released on itch.io. And it's just the default configuration. The block coloring and stuff. Error highlights, the block. Ooh, that reminds me, I like to highlight line at cursor too. But the default configuration and default color scheme is what you see. It doesn't use Vim key bindings, but I know that the community that is maintaining it has like one or two different. It has a highly customizable. Come on, bring it up. What's going on here? Are we not doing Discord? There we go. Forcoder community has the community forks conversation. There's also, there's a whole like series of Vim customizations. Looks like there's a couple years since anyone's worked on one of those, so they might not be in great shape. I don't know. I didn't really know Vim, so I never tried to make Vim work with it, but some other people have, and I don't know how far they got. Yeah, Forcoder has really cool. I think Forcoder is really good, but of course I'm biased. I designed it to be exactly what I wanted. That's why I use the default config. That's why everyone else changes it. But it works really well for me. So layout section. Section layouts. Lay section. VOF plus label off. Okay. Okay. Seg fault. Okay. Okay. Huh. Okay, so the export table is still coming out empty. Although, you know what? This is going to be dumping the wrong file now. Let's go pop in over here and look at the diff. So mini DLL at 140 has RVA 8224. This one has some garbage. Absolute nonsense. Okay. Let's try to figure out why that's happening. Okay. There's one problem. Okay, so this one and this one are almost the same. The only difference now is mini DLL is putting a little bit of stuff before the export table, and I am not. What is mini DLL putting before the export table, I wonder? R data. 1536 600. Timestamp, major version, minor version, debug type, size of data, virtual address of raw data, pointer of raw data, debug type. Okay, I think if we go look over here, we might find that debug characteristics, timestamp, major, minor, debug type, size, VOF, FOF Yeah, so they put a debug directory down for those first 2 lines. So that's why export flag starts right here. Okay. Okay, so we don't need to parity that exactly. We can just be close. But here we have another difference. The size of mini DLL is 44. And the size of generated DLL is 39. Let's think about why those are different. 'Cause they might need to be different too. But let's take a look. So right here, it says it has a size of, it's not 44, it's hex 44, so 68. Okay, so it's going to be like 10, 20, 30, 44. And so this contains export flags, export time, date stamp, major version, minor version, image name, which is actually the VOF to mini DLL, I assume, export ordinal base, export address amount, export name pointers amount, export address table RVA. So these are the VOFs to each of the arrays. This is the VOF to the actual function symbol that we're pointing at. It's pointed to by this one. Export name is the pointer to the name square right here, and it's pointed to by the pointer name RVA. This is the ordinal table. It's got a 0, it's pointed to by this. And after that, mini DLL. Okay, got it. So the main thing I am missing, if we were to look at generated, we go to generated has, it begins at 600. Let's reparse. Oh, it doesn't quite like this one. I wish I could see what the directory table expanded out to. Can we do like rerun this? How does this work? Weird. I don't know what we're doing here. Okay. Directory table. Directory table says address amount, name pointer amount. Okay, these didn't get set, so let's go fix that. That might be the problem. Interesting debugger. Zolo Renzo asks, are you reverse engineering? Not exactly. I mean, kind of. It's related. I'm not reverse engineering as in I'm not looking at an executable and understanding what it does. I am attempting to build a knowledge base and software base for generating executable files and that are valid and that, you know, that has control over all the different features you might want to control. And so I am staring at the generated version of an executable that my own generator created, right? My generator created an executable and it's kind of busted, and I'm staring at the bytes trying to figure out what exactly isn't right. And I'm comparing it. So here's generated DLL, here's mini DLL. So this one, mini DLL, also can I like make it stop? Yeah, that's fine. Mini DLL is a real DLL generated by a linker that we trust to do a good job. This one is the one that I created that is a little busted, and I'm comparing them. I've got a diff set up on my hex editor here so that I can compare them and try to figure out what's busted about mine. Hopefully that makes sense. So the things that are missing here, if we go into Gen C here, yeah, we run into this. These zeros here are all wrong. So is this zero here. We gotta actually be able to do this stuff. So let's figure out how this is gonna work. An export voff wants to point at export's label. So this needs to be a gen putter. It points at export's label. It has a label of PE table label plus the offset of putter diff PE table export voff PE table. Name ordinals. Doesn't make any sense. Yes, reload this. You want to rerun this. That still doesn't quite work. Yep, still hitting an error. We'll figure that out in a minute. Redo the diff. The diff is useless because of the fact they don't even line up. So ignore that. What I want to see is when I look at the pattern editor, I go to line 397. Okay, so it doesn't like the fact that I don't have the image name inserted yet. So let's go and fix that too. Closer, we're loading the procedure successfully now, which means that the export table is good enough to get us to the procedure. It's not executing properly, so our labels might be off or the code might be busted or something, but that's close. Hey, Young Lane, welcome. One Veneer, hi, is function an empty macro? Not exactly, it's close. Let's see. So function lives in my little keywords header. Just for my own private code, I like to have these nice tight keywords before I make them public, or make my code public. And so this is going to a thing called comp time. Comp time is the compile time resolved symbol. In other words, if we were to look at this, we would just see, that means static. It resolves at compile time. So the linker never sees a symbol that is marked this way. And all of my functions are just marked as static unless it's like I need a linked version of a function or a dynamic version of a function. But default functions aren't seen by the linker. They're handled by the compiler. Right. Okay. Now, so it's pretty close to working. I wonder where to pick up next. So yeah, so the pattern editor is happy again too. So the question is, can I take a quick look? Here's my exports, image name RVA, export ordinal base, export address amount, export name pointer amount. I see square. Oh, you know what's happening? One thing that's happening here is the image name on the export table isn't getting set. Young Lane asks, is there a benefit to make them static by default? Yeah, there is. So let's just do a full detour. This is actually on topic, even though it's maybe not obvious. Let me just mark off this part. This was about the all right, let's take a look. So what happens is there's your program, think of it as like this big soup of all these things we're going to call symbols. So symbols, here are symbols. And symbols can mean functions, and it can mean global variables. Basically, you can think of it as each symbol has a name and a putter, right? Right. And the name lets us do something like match it, so other places, if other code somewhere else wants to refer to a symbol, they use a name to get there. Sometimes they also might just use an index into an array of symbols or something, but somehow we can index into these, we can key them. And the pointer is a pointer into the binary of the program, right? So it might be a pointer onto some global variable, it might be a pointer to the beginning of some executable function that we want to be able to run, whatever. Now what happens is when we are marking things up with our language, we mark some of them up in 3 different ways. To use some sort of like generic terminology, we might mark them up as, let's use different colors here. So we might mark them up as compile time symbols. We might mark them up as link time symbols. And we might mark them up as runtime symbols. To match these up with C terminology, we're talking about static, extern, and export, import kinds of things. Okay. Now, what happens with each of these types of symbols is a little different depending on which one it is, right? So we have a stage here called our compiler. So I want a new color for this. Compiler, right? We have our compiler, and the goal here is to, let me actually do that again. Let me try to do a good job. We want to do a good job. Compiler, leave some room underneath. So then I can say, okay, each of these symbols is going to go, you know, all of this sea of symbols here is defined by some text file or something, right? So this is our source code. And our source code contains this along with other stuff. Now, each of these symbols goes on a journey. The first one goes through the compiler and gets resolved there, right? So as it goes into the compiler, it gets resolved. So what that means is we no longer have to pass it forward to other stages, because next we're going to have a linker. Come on, do a good job. Linker. And finally, we're going to have a loader. Right. And so a link time symbol comes in. It gets exported into an object file. Right, so this is like boom, boom. And then this is like resolved. Boom. This one comes through. It becomes a new symbol. Becomes a new symbol again. And then finally it is resolved. So in between here we get an object file. And we get a binary file. And so the advantage to marking things as static is that when they are resolved by the compiler, they can be more carefully optimized by the compiler. We can do things like eliminate them if they are not going to be used later on. If it's something that might be linked to by other object files, then it can't be eliminated until we get to the linker. And the linker has less flexibility on what it can do to remove things, right? The compiler can inline if there's a couple of use cases, but it can inline them, then it can do that. And if that works out better, then eliminate the code. It can't do that as easily in the linker stage, and it can't do it at all in the loader stage. So the sooner you resolve a symbol, the more freedom you have to optimize the uses of that symbol in the code where it gets used, right? And if you don't resolve a symbol, like right here when the compiler doesn't resolve this, it has to generate a function that is actually a callable function. It can't create an inlined version, because the only way to make something inlined is to have that context where the call happens. So there's this trade-off where having things deferred for later and later allows them to be more flexible, allows them to be used in more ways by more code, but it prevents them from being fully optimized as much as they could have been. So the earlier you are here, the more optimized you are. The later you are here, the more flexible you are. Hopefully that helps. Okay, to answer another question from the chat, just curious, what do you plan on using the PE COFF generator for? Is it to create your own compiler? Not really to create my own compiler. I don't intend to use it for um, I don't intend to use it for anything. It's more, this is a research project. So I am gathering up a bunch of knowledge. This knowledge will grow into something more interesting than a PE-COFF generator. But this is a useful starting point. I am encoding new and more information about how to do this kind of thing. Once it's gotten really good, um, once the amount of information that's there is really good, I can take more steps to show you what I'm really trying to do. But some of the things I have in mind are I'd like to make like a easy to use library for playing with this stuff so that anyone could use it to make a compiler backend, or even not a real like language compiler backend, but just a custom way of putting their own executables together. Like if you ever just wish you could, you know, bake your assets right into your executable easily and understand how that's working and make it work correctly. You know, sometimes a language, just, you know, good modern C likes just have like a, you know, bake this data in kind of directive. But what if you're using C? Why don't we just build that tool into the tool chain at a level that is language agnostic? Why don't we have the ability to piece together chunks from different DLLs into a single DLL? Why don't we have the ability to visualize how the linking process is working so we can see what executable, where the bloat from our executables is ending up at? Um, so, so the point is, I want to unlock a bunch of things that could be done if we were much more familiar with and comfortable with our binary file formats than what we are, right? I'm doing the research that other people can build on top of to do lots of different projects, is the way I tend to think about it. Okay, Young Lane, nice explanation. We're going back to this thing now. Nice explanation. Does the forward declared version and the actual function have to be marked static? Yeah, they have to match. The compiler does not like it when you forward declare something with one kind of marking and then actually define it with something else. Okay. So I want to look at this again, rerun it. Generated DLL. Cool. So now we have the image name and an export name. And that is working very nicely. And if I try to now, does that do the right thing? No, it's still wrong. So let's try to look at what is test load gen. And how does our square function work? Right, so we have a problem here, which is that this was compiled using the wrong ABI. It thinks that its parameter is in EDI, it's actually in ECX, but I need to... Here we go. All right, let's go over to miniasm. So miniasm should have the binary that actually gets the job done. All right, so there's this 5, 5. Oops, this is the wrong one. Mini, please. There it is. Copy that. Okay, let's see what we know. This last step here is the return. We know that. I think 8BC1 0F AF OXC. That can't be. That has to be two instructions: MOV EAX CAX, IML EAX EAX. Let's go and see if we can figure those out. It's going to be kind of an interesting thing to do. Felix, tell me about the mov instruction again. Mm-hmm. Mm-hmm. Hell yeah. Okay. Mov EAX ECX. How does it work? We're looking for 8B. 8B, R32, R32. Yes, but how big is that? Well, maybe we can chop this up the other way. Felix, Imel. Okay, we're looking at 32, R32, R32. EDX, EAX. EAX. Double word register. Double word register. So that's going to be 0F, AF, and then one more. 0F, AF. Okay. Gotcha. So you are mob EAX, ECX, and you are imul EAX, EAX. The rest of this goes away. That's our new square function. Hopefully with the correct ABI, we generate that. We run it. Boom. That's it. That's success. We just loaded a generated DLL and actually used the code that was in it. Now, that's cool. That is progress. I'm going to commit right there, but we are far from done. So I think this is a great point for me to take a 5-minute break. We hit the hour mark. We got a big milestone in. I'm going to take 5 minutes. And when I get back, there's a lot of garbage that I made in the rush to get this new milestone. And now we got to go and we got to pay down all that technical debt. We got to clean up after ourselves. But let's see. This is binary PE. We did successfully generate a DLL and load it into another process. Okay? So when I get back, we are going to pick it up from there and switch to cleanup mode. I will take 5 minutes starting now. Okay. Okay. Bum, bum, bum. So, let's review and make a list of everything that's a mess now. First of all, export directory info. Let's start right there. We got that. Okay. Very good. Oops. Very good. All right. So that takes care of this. Let's checkpoint that. Okay, I think we have this for now, which is that we're going to create empty sections first and then build them up. And we did this. Okay, so all of this is good. And I think we're going to clear this out. So my new current goal is going to be to massive API refactor and on section data construction, something like that. So let me show you what I'm talking about. Young Lane asks, have you ever had a library disable one of your pragma warnings? No, I don't think so. I mean, I've seen libraries that temporarily disable or modify pragmas, but usually they restore them. And I would think it would be considered really bad form to have a header file that like turns off certain pragmas and then doesn't turn them back on, unless it was, you know, structured that way so you could have like a begin end headers, right? I've seen libraries where you have like a begin header and stuff and an end header, and the begin and end header kind of pair each other off everywhere. But like, still, the library should be responsible for cleaning up after whatever configuration it does. I mean, ideally, a good library will do that. Libraries should seek to minimize how much they change the base assumptions of a code base. Okay, so let's see here. What can we do? To make this better. What's happening is I need to be able to push that PE table and fill it later. So that part is fine. The names here are all super confusing. Let's talk a little bit about the names. So these are setters. this is data stuff. This one doesn't say data. This one is confusing. Okay. This one is not a data setter. So these are like... Okay. All right, so what we want to do here is start getting some of these things cleaned up a little bit. So the... Yeah, the weird thing is there are like times where I make a label that I don't actually want a label in the end. But I wonder if what I want to do is like, okay, why don't we start with trying to clean up these? Because this is significantly annoying. This is like PE gen, putter, V off 32. Okay, what do we think? Pros and cons here. It takes all of these 1, 2, 3, 4, 5, 6 different things to set this pointer up. The context, which section we're in, 3 pieces for the offset, because we have the base of the struct, plus the offset into the struct, which we need 2 pieces for, and then the thing we're trying to point to. Now, it would be cool if I could do something a little simpler. It would be cool if I could do like... How would that be possible? How could I ever make that work? It would have to know that this pointer is inside of this section. and use that to find the offset. It saves us this because it would calculate the offset itself. And it saves us this because it would just have the actual pointer here. So the delta off of that would no longer be necessary, right? That's really cool. So I guess I kind of would like to see if we could do that. Makes me wonder. A dedicated data structure with virtual memory, that directly works on virtual memory, feels kind of tempting here, right? Because we could do something like, say, a section is known to be no bigger than blah. We can make it 4 gigabytes to be 100% sure, because we know we use 32-bit sizes on our data sections. Or we can make it smaller and say, like, a data section is not going to be bigger than 1 gigabyte or whatever, right? Reserve that much. And then as we build them, we would have a linear buffer instead of a string 8 list. And that would really simplify and speed up the use of pointers as offsets. It means a gigabyte of reserve for every section, which could be a lot if we're talking about an object file with hundreds of sections. But if we let the user say what the maximum size of the section is, and they know they're generating really small sections, and they're willing to be like, hey, 1 megabyte's good enough for all of these sections, then they could make thousands of sections, right, without a problem. You know, with object files, those small sections, all those little sections, a megabyte would be more than enough almost all the time. You have to then, either way, you're then picking your caps up ahead of time, which leads to problems. We don't want to have to relocate because then the pointers are no longer good stable offsets. We could just do like a large data chunking data structure behind the scenes. So it would start off with, you know, a megabyte block reserved or committed even, and then add in another megabyte for each one that goes over. You know, just grow in the chaining way. And then when we want to map a pointer to an offset, we would just have to walk the chain. And so if you got to the point where your thing was the size of a gigabyte, each pointer is going to be 1,000 iterations on a chain. But how often is your data section going to be a gigabyte? If you know your data section is going to be big, maybe you can change the block size preemptively to tune things up. We could also grow the block size exponentially, so we have 1 megabyte and then 2 megabytes and then 4 megabytes. So by the time you get to a gigabyte, you don't have that many steps in the chain to walk. It wouldn't be thousands, it'd be like 10, 20. What would it be? It'd be 10-ish. Maybe 11. Now the reason we need to know the offset and section is because right now a gen putter understands itself as an offset from a section. And that is significant because when we go to apply it, yeah, we do need to know its offset from the section because we're going to be dealing with v-offs and not just f-offs, right? We're going to be going, hey, it's not just a matter of knowing where the data is. So we couldn't just store a pointer here and say, like, don't copy, make sure it grows, don't relocate the data after you've constructed it. Like, if we wanted to, we could say when we grow these sections out, we're going to put the memory somewhere, and we're not going to relocate the memory after we've placed it. And then a pointer here would always point to the correct thing. You know? Here, instead of relocating the data, we would be going gen sections. Just give me the raw data block. Or the raw data chain. Stick it here. Light sections, yeah. Okay. Yeah, I mean, we never need the data to be contiguous except for this very last step. You see this? It's risky because it locks you in pretty hard. Like if you decide to not do things as offsets from sections for these pointers, then what happens is if you ever do want to like linearize your data to check it out and then apply these pointers as an overlay, then you don't have the data formatted correctly. It's very interesting. So the reason this is interesting, the reason I'm spending so much time puzzling over it is because this API is going to matter a lot. So let's go and look at that again. We're trying to say I want to set this after layout. This way of doing it says literally here's the pointer I want to set. And this way of doing it says here is the offset to the spot in the section that corresponds to the data I want to set. And the fact that it's a little more indirect is why it's more complicated, but it's also why it works well. This could be reinterpreted into this internally. With the caveat that it takes a little more computation to do it. But I mean, like this is where it would be cool to be able to say something like, hey, I don't need a PE table pointer so much as I need a something like that, right? So that then PE table binary name voff could be understood as being equivalent to saying PE table.off plus the offset of member PE export directory table binary name voff, right? We would want to be able to use this notation for the plussing that it does. But we don't have a language like that, so question is, do I do the thing that is more directly what I want to compute, or do I do the thing that goes along with what the language has given me and do the extra compute to make that work? That's what I'm staring at. And I think, I mean, I think I have to go with this one in the end, even though it's less convenient. Let me just try a couple ways that this might be better. Does that feel better? It's a good name for this idea. It's not a bad idea, but what is it? It's an offset. It's a base offset plus a member offset. Base SM base plus offset of member V SM Okay, I think that's pretty good compromise. Base plus member off. I don't love it because I'm still switching back and forth between using the actual pointer and using these offsets. All right. Let's just see how bad it gets. Let's try that. Okay? Let's try that. Okay, that's just what we're going to do. We're going to pay the price, make the API easy to use, and see how it goes. Context, call it gen. Now, putter new. target label equals target label. Veloc off is off. Veloc num bits equals 32. So this would become, again, putter v off 32. Exports export I address of export symbol label. Name voffs ordinal I string label. Okay, and these become putter v off 32 pe table export v off export label. Name v off name v off's label. Ordinal v off ordinal label. Okay, that still works. So now all of our pointers are being set this way. Okay, so this is cool. This leaves behind a to-do. Accelerate the pointer to off mapping for section constructors. We need to accelerate that because we're doing a lot of it now, and you can see like here we did it once, twice, once per export, once per name, 1, 2, 3, 4 other times just in this section here. So it could be a lot of times, and each one, like these are all hitting pretty early because they're in that first section that we put down, but they have to scan every little push we have. So we have 1, 2, 3, 4, 5 plus all of these, so tons of pushes. It could get to be a lot. So to accelerate that, I'm probably gonna have to stop using a string list with separate nodes and start using large blocks with some kind of logic to ensure that these can always come back contiguous. but that there's some kind of accelerated pointer to offset mapping being tracked internally by that section data structure. Okay. Now, what about all these things here where we have to create the push, get the label at the same time? These, well, first of all, this function name is just garbage. This should be like label at section end, maybe? Maybe that's better. So there are other ways I could imagine wanting to do this, right? We could do... Let's play with the API here. Section data push gen sec size of PE export data directory table. Right, so this would get replaced with just this. We'd only have the label. And the only problem is that later... And these lines are getting long too. Should probably do something about that. Later, we do want the actual PE table down here. But maybe we can do something like, we've got a label here. We track for ourselves. We're gonna come in here and do like PE gen section putter from off. Gen sec, or we do putter from label. Right? And then we're manually setting the type. I'm going to actually take another 5-minute break because we're at about the 2-hour part, and then I'm going to come back with fresh eyes and see if I still like this idea. Okay? So, see you in a few minutes. All right. So the idea was, do I want to drop the PE table export, just drop the thing where I'm pushing the raw data and getting it back like that all the time? And then map that to a pointer as necessary. So the other place where this would happen is right here. You can see we've already set ourselves up to not like this method, because everywhere that I'm setting a pointer, I am already using that raw pointer type. So there's another way I might want to think about this, which is, what if I went the other way around? What if instead of eliminating that end, I just eliminate this end? I go data push, simplify, simplify, simplify. Maybe I have like data push array, grab one of those. That does the cast for me automatically. And then when I want a PE table label, well, I won't want one there, so that's fine. But let's say I'm this one. It would go push array. These would go out. These would go out. Exports is good. And then right here, I need an exports label. And so to get that, what I would need is PEGen label from pointer. Gen sec exports. Right? Ordinals and name VOFs, binary name label. Again, that could just become like this. Oh yeah, I do like this. So we'll do everything. Let's just try it. Name VOFs, table name count, 16 ordinals, 16. So everything here is now in the space of process level pointers of the generator. And when we want to, we can map those into labels. And we're going to count on the acceleration there being good enough. This way we have a unified local language. It's all data. I mean, it would get even better. Check this out. It would get even better if we didn't need to remember which section the pointer came from, right? This pointer came with this section. What if you could just do this? What if it was just a void pointer and we actually had the ability to go from pointer to label all on its own? Do you know what I'm saying? It's like... Yeah, so here's the thing. I know what we have to do to make that work. I think it might be worth it. But it's a lot of work. I'm trying to think if I'm overdoing it right now. I mean, I could just let it keep running the slow way for a long time here, right? I don't need to speed it up. It's just that the acceleration I will eventually have to do is going to be a lot. It's going to be a lot of work. There are a bunch of upsides to doing things this way, though. If I default to always talking about the raw memory, then things like directly manipulating the memory when I know just raw data that I want to put in is trivial. If I were to do something the other way around, if I made the unified local language always being labels, then there's no way to use the C language's built-in struct typing system to do things like what I have here for the PE table. I can't use the array indexing system of the language to access things like this and this, right? And so that leads to the code being so much more complicated if I can't do those things. And so what we're talking about... Okay, I've already like changed a bunch of this code to the point that like I either have to commit and try this, or I have to figure out how to back it all out. So I'm gonna just commit to trying this, but it's gonna be a while before we get everything building again. I'm not gonna do an accelerator for it today. We're gonna just make it work as is. So we're about to do some massive refactor on this API now. This is the sort of thing where it's going to get all hardcore mode, so I'm going to need, you know what, honestly, we're activating standing mode. We're turning on some big work music vibes. Let's get to it. Just Jam In by Grammatic, to answer your question in chat. That's what I am currently playing. I can't play it through the desktop because then I'll get copyright stricken. So, look. Let's see if I can do this. Look. Here's my playlist. You know? Is that true? You know what? If that's true that they can automatically remove copyrighted background audio without ruining me talking, if they can remove background audio without ruining me talking, then I guess I will try that sometime. I don't want to try it today and ruin this VOD if it doesn't work. And I also have a local copy that I'm recording for YouTube, which would also need to get stripped. And that would have to follow YouTube's rules rather than Twitch's. You know what I think I'll do in the future? Is I'll probably set up like some kind of listen along. I think Spotify has features for saying like, hey, if you want to listen to the same music I'm listening to, just like pop on this link here. And so if y'all really want to hear what I'm hearing as I'm hearing it, we could do it that way. Interesting. Well, I will experiment with that sometime when I'm not already in the middle of a VOD that I don't want to mess with. All right, this part is interesting. I have to talk it out. So the interesting thing about bake exports is it's kind of like a data push, right? It's like we have this one where you put in some data, it grows the section, and it copies some data in. This is just like a more complicated way to copy data in, right? It's structuring the data as it copies it in, and it's creating pointers as it copies it in, but ultimately it's the same thing. And in a way, we kind of want to get this thing back out, but we also want to get the size back out. Here, the size was not something we needed to return to us because it was built into the call. So we can figure out what the size is of the thing that just got pushed trivially. Here, the size was determined in the process. So there are two ways we can find out what the size is. One is we can take whatever came back, and then we can take this, this, and the difference between those two pointers gives us the size. That's one way we could do it. We could also say that this is going to give us something like this, and then we're looking at exports dot putter exports dot size, something like that. Now the question is why? What's the point? What's the point of doing this? Well, I'm trying to make the language at this level match the basic idea of the language at the lower level underneath it. I want the pattern at the lowest level and the pattern at the next level above to be as similar as possible, because that lets these things stack and stack and stack, right? If the patterns, if I can take some structure that is small and piece it together into a larger structure that has the same basic shape, then I can continue to stack those things up. If the structure keeps changing as I stack things up, it makes code more complicated. So I would like them to match as closely as possible. And the language that I picked was to return pointers, which are pointers to, which are in the generator's address space. C-style pointers in this process's own logic, and have a mapping from that to the VOF space that we're creating through these labels here, right? So if I want to maintain the same language, I'm still talking about returning pointers. The first problem to watch out for is that these pointers are guaranteed to be contiguous, right? Because they are single isolated pushes. I'm guaranteed that each one of these is a contiguous range. This is not guaranteed to be a contiguous range because it is made up of multiple of those small pushes. So that is a difference between the small layer and the big layer that I have to watch out for. And so if I just did this, my concern would be that it implies that these things are the same, that like all of the stuff that got baked here is contiguous, and that's not true. Now I could try to force that to be true by being careful about how the allocators work, giving each section its own very large reserve. Or I could say there's going to be a slight shift by doing this. So whenever the thing returned is a pointer where we don't need to return the size because it's going to be one contiguous block, we just get the base pointer. But if we are getting a pointer that may not be, if we're getting a range that may not be contiguous in our local memory, then we'll get first a base pointer and a size. That's fine, I guess. Like, it's a little bit of a mutation of the pattern, which I'm not in love with, but it seems fine. This would end up looking like this. Could be like that. This could be like that. This could be like that. Let's go for it. Can't think of anything wrong with this right now. I think something will pop out later. This doesn't feel 100% right, but maybe I'm overthinking it. Segfault. I need to be able to hear myself talk out loud for debugging purposes. Target is null, huh? Shader Keeper asks, what's wrong with MSVC, CL, or Clang, or GCC, etc.? You could, in theory, make your own object files and get pretty much anything into a PE file for free. Sure, how can I get things out of my PE files, for one thing? And just because I can get something into a PE file by, like, turning it into some C data and baking it in there, do I really want to have to say I'm making a visual tool for manipulating my object and executable files, and I need to also hook up this text mode backend thing so that in order for this to be a viable tool, you also have to be competent at setting up a compiler and setting up all the paths for them and stuff like that. Like, all of that stuff works, but, like, depending on it to solve the problem means not knowing what else you could do. Well, decompiling has a lot more to do with, like, disassembling it and figuring out what structures likely matched from the source code, but deconstructing it so that, like, you can piece apart, like, where are the symbols here that matter most, where are the pieces I'm actually going to call into from an outside user. Yeah, I want to be able to make them less opaque. I want to be able to visualize them. I want to be able to visualize the linking process. I want to be able to visualize what's inside them, where that stuff came from. IDA? I don't know what that is. Let me take a look. Ooh. The hex rays thing? This looks really cool. I'll put this on the list of things I might check out later. Okay. Cool. Yeah, I've had Ghidra recommended before, but I didn't want to have to do the whole, like, if you looked here, it's like you got to do, like, a Java version and stuff. I'm just like, this is a lot. I don't want to do that. Cool. Well, I will check it out. I like to see what people have already done and see if, if I'm doing something that has been thought of before and it has been explored, then I'm not doing good research. So I'd like to check that out. Thanks for the recommendation. Okay, so we're trying to figure out why the target label is coming up null. That would be related to this right here, line 281. Okay, so it's gone through all of these and didn't find any matches. Double check I didn't make a mistake in here. Notice streams less than equal to putter and putters less than or equal. Well, that's actually wrong. Well, I guess it's right. Off cursor plus the difference from putter to there is the amount of extra. This is a label, an ID, but that's coming from target. Why am I not able to? Okay, and that's coming from symbol label. Well, that's not good. That shouldn't be a label. What is this? Putter to fill the export. Okay, so we already have the label in this case. Yeah, we do want to be able to support that because sometimes we don't have... maybe I want to be able to do... it's hard to say. It's a little hard to say. So I could just say this always takes a label, and then anywhere where you had a raw pointer, you do an extra call to this. Like, that's an option. I don't know if I like that. Take a look here. So there's a label, there's a raw pointer, raw pointer, raw pointer, raw pointer, raw pointer. I'm going to end up making a lot of different versions of each one of these. I think that if for now I'm going to let them proliferate, and later I think they'll collapse. But trying to figure out how they collapse right now feels like a waste of time. Let them proliferate first and then collapse them. So this is going to be like this, except we don't have to figure out the target label, we just have it passed to us. And so then this is like this, except we have to figure out the target label, and then we call gen putter target label off 32 label. Now the only fear I have is that I'm going to end up making this mistake a lot, because void pointer will work for anything, which means if I have a label and I mean to use the label, I have to remember to type label here. But if I don't type label, then it'll still accept the label and fail. Right? So one thing I could do is to wrap this and force this to be casted. Right? I can make a dummy type and say, okay, whenever you use a VOF32, you do have to do a cast. So it'll be like symbol labels, fine, but these will have to be like something like this, right? Well, that wouldn't have to be it, but this would have to be. I don't know. Something like that. Something like that. I mean, I would still have the same problem, which is I could copy paste this, put a label in there, and forget. I think it's just not something I'm going to try to solve. Don't think C is good enough for this. That's fine. We'll catch it as early as possible by doing assert target label does not equal 0 instead. Okay, so that works. Woo! That was hardcore mode. We've done it. Completely rearranged the way data pushing works and the way labels and pointers work. So now the bake exports code looks like this. We place the directory, the exports array, the voffs array, the ordinals, the binary name. We loop through all of the exports. We place pointers on each of the exports in the export array to point to the correct symbol. We loop through all the names and add them to the directory, and then have the name voffs point at those. Finally, we set up the PE table and fill in the pointers as necessary there. And return the result size. Like, this all looks very, like, that's a language I can use to build lots of these things, right? That seems good. Cool. I'm going to check that part in. Call this and then let's see, how far are we into this? 10 minutes? I think that's enough time to just sneak in one last little thing today. We're kind of on a roll. This to do right here says, hey, why are we doing gen labels as pointers? These things are only 8 bytes to begin with, and my pointers are 8 bytes, so I'm kind of just throwing an extra 8 bytes in here by using a pointer to this as well as this everywhere. I could just pass these around as if they're 8 bytes, right? So here we go. Anywhere where we see gen label treated as a pointer, let's just switch it out to not being a pointer. Fear of Code asks, do you do this full time? And the answer is yes. That's why I started my lab, the Mr. Fourth lab, so that I could full time do this. And that's why I count on supporters and members to pitch in, because I'm spending all of my work time trying to do this kind of research, and I'm hoping that people will value it so that they can pitch in a little bit to make it possible for me to keep doing it full time. I believe once one of these projects comes out that it'll become obvious why this is valuable work and why it's hard to get it funded any other way. But we'll see. We'll see if it catches on. Cool. All right, so that's still all working, and now okay, I think that'll be it for today. We have done a whole lot this week, and especially today on stream. Yesterday I did a lot, but only some of it was on stream. Today we did a lot, and it was all on stream. And just to recap, we are now at a point where I can generate a DLL and load it into another process. I can create an export table, and it correctly bakes the export table. I can like bake into these sections all these pointer fix-ups, and the layout system automatically adjusts all the VOFs afterwards the right way. So that is all really cool. I'm not entirely sure what we want to do next. We might want to look at section layout constraints. We might want to look at this acceleration problem. We might want to look at base relocations. We might want to look into some of these other harder things to reach for. I don't know. I've got a weekend now to figure out what the next big step for this project is. But this feels like a good milestone. I don't have a current goal anymore. So we'll be thinking about that for the weekend, and I'll come back with some plans on next big steps for this project. If you want to see me keep working on this project for a long time and get the cool ideas that I've been talking about off the ground, I would appreciate it if you can to go to mrforth.com/membership and become a supporter or a member. I'm counting on people like you to keep the project going. So take a look, see if these perks are are valuable to you, or if it's not about the perks and you just like my project, that's great too. You can save some by doing a yearly support instead of monthly support. So check it out. And I appreciate you coming and hanging out and checking out what I'm working on. I will see you around the internet. Bye.